Hello, good evening. This is Chris. We're going to talk tonight about compass problems. And compass problems are really an integral part of many other problems that you could see on your U.S. Coast Guard Merchant Mariner exam. And then if you're outside the U.S., you could see this stuff on your host nation exams as well. It's all very similar, and these are integral to other types of problems. Most commonly, you're going to see these in the chart plotting section, where you're actually working on a chart and there's some information regarding compasses that maybe is designed to trip you up. You'll also see some of the theoretical concepts in the navigation general category. But what we're going to focus on tonight is the navigation problems section. And so some of these are, they're mostly arithmetic. They give you a bunch of numbers and you have to come up with a value, whether it's at the near coastal or the oceans level. And often they're a part of a larger problem inside navigation problems. So I think it's a good skill set to have. As we go on through the broadcast, if you've got any questions, go ahead and drop it into the chat box on the window, or you can send me an email at chris@practicalnavigator.org and I'll respond there. Okay, so the first thing I wanted to talk about is you might think this is a magnetic compass, and that is sort of the case, right? It works on the principle of aligning itself with the magnetic lines on the Earth, right? If I was using this to steer my boat, right, it's not actually a magnetic compass for that purpose. It's a steering compass. And so when I look at this and I look that way, I see it's a course of northwest. It's important to note for vocabulary purposes that this is a compass course and not a magnetic course, right? So there's a difference between magnetic courses and compass courses. And you might be asking yourself, what is that? Well, hypothetically, let's take this compass, this steering compass, and we'll put a phone next to it. And you may be able to see in the image there that the compass it starts to deviate a little bit, like it wanders a little bit. And that's one of the main problems with these is deviation. So the first vocab word we want to talk about is deviation. And deviation is really best summarized very quickly by saying everything that is going to mess this thing up, right? So what is causing it not to point exactly where it should point is deviation. Everything on your ship is doing that, right? And so if you had a ship, theoretically, you're going to have some wiring running through it. You're going to have some engines. There's going to be phones and electronics. Those are all going to add up to influence this compass and cause it to deviate from a true magnetic heading. And so that deviation is everything inside the ship, right? So important to know that deviation has to do with the ship. And so if you were to take this steering compass and look at it and take your course that you want to steer your boat at, you would need to apply deviation to get the real magnetic heading. So deviation is going to help you convert between your compass course and your magnetic course. There's another vocab word you may have heard of, and that doesn't have to do with your ship so much. It's called variation. That has to do with the Earth itself. And so if you think of the Earth, it's got a North Pole and a South Pole. Santa Claus is up at the North Pole. I don't know what's down at the South Pole. Somebody can tell me if you're familiar. But there's lines of longitude that run between them, and they align at the poles and they deviate at the equator at a maximum deflection, right? So these are lines of longitude or meridians. Well, there's also a magnetic North Pole too. So there's a magnetic North Pole, and it's not at the exact North Pole. And there's a magnetic South Pole as well, and they're not aligned, right? So it depends where thanks Mick there for the entrance to the hollow Earth. I like that. So it depends where you're at on the Earth, but the short version of variation is you can think of it's the difference between true north and magnetic north. That's an easy, quick way to think about it. The real way to think about it, and something you might see on a vocabulary question on navigation general, it's the difference in these meridians. So the magnetic meridian and the true meridian are off at a certain angle. And that angular difference between the magnetic meridian and the true meridian is defined as variation. And so if you took this compass course that you measured and you applied deviation to it, you would get a magnetic heading. And then if you applied variation to it, you would get a true heading. And so if you ever wanted to plot on a nautical chart generally you're going to plot true bearings on this, right? And you're going to read compass bearings off this. And so when we talk about magnetic, it's an interchange thing there between true and compass. So vocabulary wise, it's important to be precise when we talk about this for Coast Guard purposes. In everyday language, it's a little bit of a different story. Okay, now what types of problems can you see? What are we here for? We're here to solve navigation problems. So like I said earlier, on chart plotting problems, it's often going to give you some information and you then have to make a correct decision to plot on your chart. We're going to focus on navigation problems, and we're going to work through 7 or 8 of them, about a couple of different types of problems that they can give you. So there's a bunch of problems in the video description if you kind of look below, and then I'll also drop things into the chat window here from time to time. But let's just say you wanted to make a course good, which is course made good, of 330 degrees true, right? And you were told that the variation is 15 degrees east. And now what's the deal with that east thing? Well, think about it like this. If your ship is, say, pointing north and there's a compass here at this red dot, the compass could vary a little bit to the east or a little bit to the west. And why is variation going to impact it? That's going to be because of the Earth. Likewise, if there was some metal or some electronics on the phone, right? You could deviate the compass a little to the east or deviate it a little bit to the west based on the deviation of the compass. So all of these, the variation and deviation is always going to give you a direction as well. So it's either going to be east or west, right? And so likewise, say the deviation was given to you as 2 degrees west. A typical Coast Guard problem might ask you, what is the course per steering compass? PSC. And that's important. The acronym PSC stands for per steering compass. Sometimes you'll see it as per standard compass or per standard magnetic compass. The questions that are in the Coast Guard database are not actually consistent in terms of that. So PSC. So in summary, you want to make good a course of 330 on your nautical chart. The variation is 15 east. The deviation is 2 west. What do you steer on your actual compass, right? So you start out on the chart, you measure something, and you want to turn it into whatever you're going to steer behind the compass. How do we do that? Well, there's a couple ways. Variation and deviation, if you were to sum them up and kind of take the absolute value of them, in essence, one way or the other, that's going to be what's called compass error. Compass error is the total of variation and deviation. So in this case, it's 15 east, deviation is 2 west. The total compass error then is 13 east, all right? So it's the number and then also the direction. You kind of add them up together. So some people like to do that, and then you can apply the compass error to true and get your PSC. I'll show you a different way. The way that I like to do it is it's a little memory aid that you can use to help you out. And so the letters are going to be TV, MDC. And you can come up with any kind of acronym for it. There's some that are more traditionally sailorly, but the one we're going to use is true vampires make dull companions at wakes. And so for anybody that this is a second language for, what is a vampire? It's a creature that comes out at night and sucks your blood. What is a wake? In some religious traditions, you allow a body to sit there while you view it. So the story is true vampires make dull companions at wakes. And what do all these things stand for? The T stands for true, right? So if you wanted to make good a course of 330 true, that's going to go in this category here. V, you can probably guess, stands for variation. And so that's 15 degrees east in this case. M stands for magnetic. We don't have any information in the problem regarding that. D stands for deviation, which is 2 degrees east. And then C stands for compass, and that's what we're looking for, the compass heading. What's this at wakes or AW? It means add west. So if you're going to use this tool or this memory aid and you're working in this direction downward, you need to add everything that's west and therefore subtract everything that's east. You could also work in an opposite direction. We'll get to that in a minute. So true vampires make dull companions at wakes. True heading, variation, magnetic heading, deviation, and then compass. In this problem, we're given a true heading. We're looking for a compass problem, so we're going to work through the memory aid this way. And so 330 and 15 east. If we're working down, we have to add west, and therefore, in this case, we have to subtract east, right? So we're going to get 315 degrees magnetic. And now the question for you is that what you read on the compass? No. Magnetic is this kind of intermediate step. There's also the deviation, the phone next to the compass or the electronics, whatever. We need to apply that as well. So 2 east. So in this case, it was 2 west. 2 west, right? So we've applied the variation, and now we have to apply the deviation. We're going down through the acronym, so we need to add westerly things. So 315 and 2 west is going to be 317 degrees PSC per steering compass, per standard magnetic compass, and we're good to go there. So that's a typical problem that they could give you on your navigation problem section. Like I say, most often it's part of a larger problem that you could see. Just to reiterate the point, let's do one more of these. And in the meantime, I'm going to drop in the first problem into the chat box. Just give me a second. And so the answer there is going to be 317 PSC. So if you're feeling good about these and you want to try and work through one, it's in the video description below. Or here's the next one that we're going to work on. So you desire to make good a course of 140 degrees true. 140 degrees true. You take that off a chart. Maybe that's the bearing between 2 objects that you want to steer on. Variation, right? That's due to the Earth. It has to do with the difference between magnetic and true north in a short version, or in a more appropriate version, the angular difference between the magnetic and the true meridians, right? Variation is maybe given to you as 12 degrees west in this case. Deviation, right? Deviation is based on the ship itself. It's all the metal and the electronics and all the things in the ship that are causing the compass to deviate. Deviation in this case is 1 degree east. What course do we steer PSC? What course do we steer PSC? So we have a charted course, we've got a variation and a deviation, and we want to know what we're going to steer on the actual compass. If I'm steering the wheel behind the compass, what do I need to look at? Right, well, I would encourage you to remember the memory aid. True vampires make dull companions at wakes. And if you fill in the information you know, true is the course made good, that's 140. Variation is 12 west, right? And so if you're working through the tool this way, you have to add westerly things. You have to add westerly things. So we're going to end up at 152 degrees magnetic. Is that the final answer? Nope, it's not. Let's see, Paula, 151. Let's see, am I missing something there? Oh, yeah, okay, you're going for the answer. Gotcha. Yep, you're right, exactly. So deviation in this case is 1 degree east. And if we're working this way through the acronym, we need to subtract easterly things. So the final answer, yep, exactly as Paula says, is 151 degrees PSC. Per steering compass, per standard magnetic compass, is unfortunately the inconsistent language that they're going to give you on US Coast Guard exams anyway, so PSC. So this is kind of your boilerplate compass problem that you're going to see. What we're going to do now is kind of increase the complexity just a little bit and talk about some other stuff that can interfere with it. So if you've got a question, drop it into the chat box as well, and we'll move on from there. Okay, so what would happen if instead of them giving you a course made good, right, in the third problem we're going to work, which is in the video description, or I will drop it into the window right now. What if they actually give you a compass course, right? So it increases the complexity a little bit because we haven't talked about that. So if you wanted to, if you were steering, say, a compass course of 195 PSC, and you want to get to what you can plot on a chart, right? So you're going to see the variation is maybe given to you as 12 west, and the deviation is given to you as 4 east, right? And Guy asked a great question there. The deviation in a real world situation, it's not always given to you, right? That's exactly correct. What you would need to use is a deviation table. You would use a deviation table. And so a deviation table might look like this. So we're going to talk about that in just a little bit. But the short version is that a deviation table, about once a year or so, at least once a year on military vessels, some old timer is going to come out on your ship. You're going to swing it in a circle, and you're going to spend about an hour as he or she fiddles with your magnetic compass to come up with what the deviation is for each heading. And then you would have a little table to look things up on. So we'll get back to that in just a moment. But for now, the deviation is given to you. So you were given a compass course. You've got a variation and a deviation. And now you want to know, what is the true heading? What is the true heading? Well, I think the same thing applies. True vampires make dull companions at wakes. If you only remember one thing, that's what I would recommend you remember. In this case, we're going to start here and we're going to move up. If you choose, there's another memory aid you can remember. Can dead men vote twice at elections? And no election jokes from the news, right? There's a lot of weird stuff going on. But can dead men vote twice at elections? And so if you're going this way, you have to add easterly things and therefore subtract westerly things, right? So personally, I always just remember the true vampires make dull companions at wakes thing, and I just work backwards if necessary. But can dead men vote twice at elections works as well. So let's fill in what we know. C, or the compass course, is 195 degrees PSC. Per standard compass, per steering compass, per standard magnetic compass in the language of the problem. D for deviate this way, do we need to add easterly things or subtract easterly things? Well, we're going to add easterly things, right? So we end up with 199 degrees magnetic. So what's magnetic? Again, is that this? Not exactly, right? This is a magnetic compass in the lingo, but it's truly a compass. Magnetic is a type of heading. It's something that we're going to use as an intermediate calculation. Variation is 12 degrees west. Variation has to do with the Earth, where you are on the Earth. So we're moving upwards in the acronym. We need to add easterly things and therefore subtract westerly things. So we end up at 187 degrees true. And that would be our final answer in this problem. So hopefully you can see that this tool is pretty useful. True vampires make dull companions at wakes. Depending on what they're giving you, you can plug in that numbers and work your way through it from there in either direction. Now, as a question was asked, what's the practical use of this stuff? If you're out on your boat in real life, a lot of this is kind of academic. You're really just going to make adjustments on the fly as you see that you're not in the right position that you thought you were. But for testing purposes, particularly in the navigation problems section, attention to detail is tricky, and you have to work on that. Okay, the next topic I wanted to talk about regarding compass problems is gyros. Gyroscopic compasses are the kinds that always point to true north. So wherever the ship is, it's like a little spinning top down there. You're going to find these on larger vessels, and they're tricky pieces of machinery. Incidentally, unrelated at all to our navigation problems discussion, if you change your latitude by a significant amount, you have to tweak that gyro compass just because it's going to get pointing in a weird direction. So just an interesting fact about gyros. We're not talking about sandwiches. We're talking about things down in the lower portion of the ship that are going to affect your steering and your navigation. So the gyro compass always points to true north. It's a piece of machinery, and it is subject to error as well. And these are generally small problems, but gyro error problems are often found on the navigation problems near coastal or oceans tests. And so we learned an acronym in the last type of problems: true vampires make dull companions. Here's another one for you: GET. And the thing to remember here is gyro plus easterly error equals true. So if you remember GET, gyro plus easterly error is true, you're going to be all set with these type of problems. There's another acronym you can remember: gyro best, error west; gyro least, error east. This is the one that works best for Coast Guard problems, so that's what we're going to stick with. So GET, gyro plus easterly error is true. And as an example, if you look at, I think, the fourth one in the description to this video block, or what I'm dropping into the chat box right now, you can see that you're given, you're trying to solve a gyro error problem. And so you're given a track of 274 degrees true, right? Where do you think that goes? It goes into the true column, 274 degrees true. So if your track is 274 and the gyro error is 1.5 east, 1.5 degrees east, what is the gyro heading that you should steer? And so I don't have a gyro compass I can show you right now, but it's just a thing, and it looks like that. You know, it's a thing that you're going to steer on. And so if the true heading on a chart is 274 and there's a little bit of error in that gyro compass that you know about, what do you have to steer in order to make that course? Well, what you're going to say is something plus 1.5 is equal to 274. Gyro plus easterly error is true. Since this is east, something plus 1.5 is equal to 274. And so in that case, it's just going to be 274 minus 1.5, or 272.5 degrees PGC. 272.5 degrees PGC. PGC stands for per gyro compass, per gyroscopic compass, is some of the lingo that you would see on your exam, right? So the gyro error problems, the thing to remember is GET, G-E-T, gyro plus easterly error equals true. So if you're given a true, you apply the easterly error to get to the gyro compass course there. You can see these problems in a different way, gyro problems as well. And I will drop the next one into the box here. Often you're going to find with Coast Guard problems that it's really just the same thing phrased differently. So in this case, you are steering on a range, and the range is 221.5 per gyro compass. So we need to take a little break here to talk about what is a range. If your boat is out there navigating along and you see two objects lined up exactly with you, you can measure them on a chart and know that you are on the range. Sometimes these objects are natural, like a house and a cupola, for instance, on a chart, and sometimes they're put out there by the government, right? Could be like two boards out there, and if you see those boards lined up, you know you're right on track, and so that's a range. And so in this problem, they're saying that the range is 221.5. True. So that came from a chart. You measured it, right? And let's see, what else do they say in the problem? You cite a charted range. The chart indicates it's 221.5. You measure it using a telescopic alidade, and you measure the gyro compass course of it to be 223. So another little break. What is a telescopic alidade? Telescopic means you just kind of look through something, and an alidade is a thing that sits on top of the gyro compass so that you can very accurately measure bearings on it. So you see them on larger vessels, on military vessels, and big commercial vessels. It's just a measuring tool to help you see it. So we have a true bearing from a range. We measure it with our gyro, and we want to know what is the gyro error. Well, the thing to remember here is GET. Gyro plus easterly error equals true. So let's plug in what we know. The gyro was 223 per gyro compass. The range was 221.5 true off of a chart. So what's the difference? The difference is 1.5 degrees. And then the question is it east or is it west? Right? Gyro plus easterly error equals true. So we went 223 minus 1.5, which means that our error is going to be west. Our error is going to be west. And so I mentioned another saying that you can remember. If gyro is best, the error is west. If gyro is least, the error is east. In this case, the gyro, 223, is bigger or best than the true value of 221.5, so the error is west. If the gyro were less or the gyro were least, the error would be east. So just like the true vampires thing, I try and only remember one acronym if necessary. So gyro plus easterly error is true. That's going to get you there every time. If you choose to go the gyro best error west thing, it'll only make your life that much easier. So far tonight, we've talked about a little bit of the theory behind steering compasses, magnetism, how it affects the compass on your ship, and true bearings and variation. We've also talked about gyro error and gyro compass bearings. What we're going to move on to next is determining the deviation. So sometimes you're going to want to determine the deviation, and a lot of problems are going to be given to you in this format. Like I said earlier in the broadcast, a lot of the questions are part of larger problems, and a lot of them are going to be on your chart plotting, but these type of questions are found routinely on your navigation problems section, both near coastal and oceans. So if you look in the video description, there's the next problem, and I will drop it into the chat box here as well. And there's a character limit on my chat, so it's just going to take a moment. All right, so in this case, you're proceeding up a channel, and you're on course 010 degrees per gyro compass. You notice a pair of range lights in alignment with the masts of your vessel when viewed forward. So in essence, they're just telling you that you're on a range, just like we talked about in the last problem. A check of the chart shows that the range to be 009 degrees true and the variation to be 15 west. If the ship's course is 026 per steering compass, what is the deviation? So this is a deviation determination problem, and we're going to just write down everything that we know, right? So the channel was 010 per gyro compass, right? They don't give us any kind of gyro error, so that's interesting. The true range, when you lined up those two objects, the true range was 009 degrees true. And then it also told us that the variation, which has to do with the Earth, where you are on the Earth, the difference between magnetic and true, or the angular difference between the geographic and the magnetic meridians, more precisely, was 15 degrees west. The deviation is what we're looking for. And then it said that we were steering a course of 026 PSC. So PSC stands for per standard magnetic compass, per steering compass. It's just this guy here. So you happen to be steering behind that, and you're steering 026. Right? And then all this other information is there. So this right there is distractor information. It's not necessary to solve the problem, but just as an exercise, could we determine the gyro error based on this? You sure can. If the gyro is 010 and the true is 009, GET, gyro plus easterly error is true. So 010 per gyro compass. Don't have that. True is 009, true. Gyro plus easterly error is true. So 1 degree west minus westerly error. So it's not a part of this problem, but I just included it as a little bonus there. So this is distractor information. It's gone. So really, we've got a bunch of pieces of information to a traditional true vampires make dull companions problem. Okay. So true vampires make dull companions at wakes. Back to one of the first things we talked about tonight. and we'll fill in the information we know. True is 0, 0, 9. Variation is 15 degrees west. Deviation is what we're looking for. PSC, our per standard magnetic compass, our per steering compass, is 0, 2, 6 PSC. So how do we get to that D? How do we get to that deviation? Right, we're going to work through the problem as much as we can, and we'll fill in everything that we can figure out along the way. So if we're going this way through the problem, we have to add westerly things. We have to add westerly things. So 0, 0, 9 plus 15 is 0, 2, 4 degrees magnetic. So is that the final answer? Nope, that's not the final answer. It's a thing you could lay on the chart. It's more of an intermediate calculation, the magnetic there. But what we can do is say that if the compass course is 0, 2, 6 and the magnetic course is 0, 2, 4, we can now determine the deviation. The deviation is going to be 2 degrees. Similar to the gyro problems that we just talked about, you have to determine whether it's east or whether it's west, right? And so if you're working down through the problem, you're adding westerly things. So in this case, we're going to add the 2 from 0, 2, 4 plus 2 to get 0, 2, 6. So 2 west would be the correct answer there. So what is the deviation for the present heading? 2 west, all right? So in summary, we had some gyro information that was distractor information. Coast Guard's always trying to trick you. And then we filled in everything we could figure out from the problem. We wrote it down on the side. We used our memory aid, true vampires make dull companions at wakes, and we solved for what was missing, the deviation, 2 west in this case. All right. Shall we do another? I think so. Another type of problem you can see having to do with compasses is leeway problems. Leeway problems. And just like what we've been talking about so far, they're often a smaller part of a larger problem. So what we're talking about with leeway, and the definition of leeway is the lateral distance downwind of your intended course. You know, you're pushed by some wind in essence. So if you had some wind from the north blowing in that direction, and you were trying to take your ship to the east, if you were set down by the wind, you had some leeway, right? So if this is your intended course and this is where you ended up, that angle is leeway. Most commonly in real life, you're just going to aim your ship a little bit higher and take care of it that way. But if you wanted to quantify it, or if you had it in a problem, this is the way to do it. Really what you do is you figure out this angular leeway, and then you either add or subtract it to your base course to get where you're going. So here's an example of that. And incidentally, they're always going to throw in something else as well. So let me just drop this into the chat box there. Or it's located down below in the notes. And so in this case, we're given a whole bunch of information, and we want to know what's the course to steer to make good a true course, right? So you desire to make good a true course of 0, 4, 6 degrees true. That's what we want to do on a chart, right? We go down to the chart room and we see 0, 2, 6, or 0, 4, 6, and that's what we want to make good on the chart. The variation is given to us, and that's going to be 6 degrees east. Incidentally, where do you get deviation from in the real world? Well, there's a couple places. Generally, on a nautical chart in the middle here, there's going to be variation. This chart says VAR 10 degrees 45 minutes, and it gives a certain year and a certain annual increase or decrease. So you can get the variation off the chart. It can also be given to you in a note on the chart, or depending on the area, like if you're working with electronic charts, it's often going to be a little data field that you can see up in the corner. In this case, the variation is 6 degrees east. Deviation is given as 12 degrees west. And that's pretty crazy, actually, to be honest. It is an official Coast Guard question. I pulled all of these out of the data bank. But yeah, that's a really large deviation. Something's wrong with your deviation table or your compass if that's the case. So you should probably get that fixed. But in terms of math, it doesn't really matter. The gyro compass error is equal to 3 degrees west. Okay, good to know. And a northerly wind produces 5 degrees of leeway. So northerly wind is 5 degrees of leeway. All right, so that's all the information that was given to us in the problem. What is the course to steer per standard magnetic compass to make good a true course, right? So in this case, they give us some gyro information. They give us some gyro information, but it's not actually necessary really to solve the problem. So all we have to do really is plug in the true vampires acronym. And so what's given to us? True is given to us 0, 4, 6, true. Variation was given to us as 6 east. Deviation was given as 12 west, right? And we're looking for the course to steer, but we have to account for that leeway too. So there's a little step at the very end we have to talk about. So let's solve what we don't know. If we're working this way through the acronym, we're adding westerly things or subtracting easterly things. So we go from 0, 4, 6 true, and we're going to subtract 6 east to get 0, 4, 0 degrees magnetic. And then we've got 12 degrees of westerly variation. Again, that's a pretty huge amount in real life. For math problems, it is what it is. So typically what we would do is we would add west in this case, right? So 0, 4, 0 plus 12 is 0, 5, 2 degrees PSC. Normally that's where you end the problem. But since they put this little bit of information in there regarding the leeway, we've got one more little step, right? So the leeway is 5 degrees from the north, And so what they're saying is that your ship is steering, 052, 046, true, 052 PSC. The wind is from the north, so you're getting blown down to the right. So you need to aim a little bit higher in order to get where you're going. And what makes the leeway problems pretty easy is it's always just either add or subtract the leeway. So if you're on the west or on the east, it's just going to depend on what direction the wind is blowing. So since the wind is blowing from the north, we need to aim more north, or we need to subtract this then. All right, so 052 minus 5 is 047 degrees PSC to account for the leeway. If we steered 052, we would not get where we want to go because the wind would blow us down. So we went through our whole compass correction calculation, and then at the very end, we added or subtracted a little bit of leeway in order to make sure that we don't get blown down off of our course. All right, one more topic to talk about in this segment, and that is back to Guy's question about the deviation table. Most often, you're going to see deviation table questions on chart plotting section. So it's not going to be in navigation problems, but it's going to be in chart plotting. So this is my low-tech deviation table, right? And so what's going to happen every year or so, you're going to go out on your ship and you're going to do what's called spin the compass, and you're going to take bearings as you spin around. And the deviation is going to be charted so that you've got a table that you can refer to over the course of the year. Now, one thing about deviation, right, is that let's think about this boat. It's all plastic, which it is in real life. Let's say this is the compass here in the middle, and then there's some little block of metal that we're going to introduce onto this into this boat. So if the ship is pointing in this direction, and the block of metal is like right here, right next to the compass is going to get pulled a little bit this way, right? And if the ship is pointing this way, the compass is going to get pulled a little bit this way. The ship is pointing this way, it's going to get pulled a little bit that way because of the metal. And so the key point there is that with deviation, it really depends on where the ship is pointing. It doesn't matter where you're looking. It matters where the ship is pointing. And you're going to really see those on the chart plotting ones. So if you're studying chart plotting, if you go to my website, practicalnavigator.org, there's some chart plotting courses available there that you can work on, and many more problems. In terms of navigation problems, which we're studying tonight, you're rarely going to see a deviation table question, but I wanted to cover it because the topic is here. So anyway, you go out, you swing your compass in a circle, you create a table. So based on your different headings of magnetic, you've got a deviation. So when our ship is on a heading of 120, the deviation is 1 east. When we're on a heading of 180, the deviation is 2 west. Sometimes you can chart these out, like you can plot them and get a deviation curve because of that. But very important to note, deviation depends on your heading, does not depend on where you're looking or anything else other than that, where your ship is pointing. So easy question. What is the deviation on a heading of 150? Well, you just look in here for your heading, you pull your deviation out, is 1 degree west. What's more challenging is when you don't fall exactly on these numbers. So for instance, what would be the deviation on a heading of 135 degrees magnetic? So 135 is not listed. It's exactly halfway between these two values here. So you could pick out the exact halfway value between these, it would be 0. So for a heading of 135, a deviation of 0 would be correct. And you can get even more particular than that. So the thesis here is that if you're solving Coast Guard navigation problems, you need to get accuracy to the nearest half a degree on your deviations, and you'll get the correct answer on all of your problems. So that's the accuracy we're looking for. You can go crazy figuring out the exact deviation, but think about like your ship is bobbing around. What's the utility of that? If you want to pass your tests, you need to get to the nearest half degree increments. And so, say the heading is 121 degrees magnetic. What is the deviation? You just go to the nearest half degree interval. 1 degree east would be good to go there. Right. So to formalize this, why don't we work on a little problem, which I will drop into the box right now, where it's located in the description block to the video. Here's the deviation table that we're going to refer to, right? So the true course between 2 points is 160. So true, 160 degrees true. That comes off a chart or whatever reason. Variation is 10 degrees east. What is the PSC, right? So it's exactly like problems that we did before, except they don't give us the deviation. We have to look it up in this case. So you're going to want to use the memory aid. True vampires make dull companions at wakes, just like before. And if you're working southbound in the acronym, you're going to add westerly things, right? And so as an example, you got 160 degrees true. Variation is 10 degrees east. So we need to add or subtract that. We're going to subtract that, right? Because it's an easterly value. So the magnetic heading is 150. Look at that. 150 is listed right on the deviation table. So the deviation is 1 degree west. And therefore, our compass course is going to be 151 degrees PSC per standard magnetic compass, per steering compass, different words they can give you in there. So it's just a traditional problem, except they don't give you deviation. You have to look in the deviation table and elucidate it that way. Rarely will they give you one that's exactly 150, right? For instance. So let's do one more. And this will be the last problem we talk about tonight in the interest of time. But if you do have any questions about this or anything that you want to talk about tonight, go ahead and write something up in the chat box and we can talk about it after the broadcast. All right, here is the last problem I'm dropping in there right now. And very similar to the other one, your true course between 2 points is 180 degrees true. Right, 180 degrees true. You get that off a chart or it's given to you in the problem. Variation is 15 degrees west. What course do you steer PSC? I don't know why I wrote it twice. Sorry. They don't give you a deviation, so we have to rely on the deviation table to do that. So I would go with the acronym True Vampires make dull companions at wakes, adding westerly if we're moving south. And we'll fill in the information that we know. 180 is the true bearing. The variation is 15 west. And so if you're working southbound in the acronym, you have to add things. So that gets us to 195 degrees magnetic. And so now the problem is you got to go into the deviation table and pull out a deviation for a heading of 195 magnetic. If I search around here, there's no 195. It's somewhere in here. Turns out it's exactly halfway, right? That's fine. But even if it wasn't, all you really need to do is estimate to the nearest half degree, and you're going to get your problems right on the Coast Guard exams. If you're really into this, you could do some ratios. You know, for instance, the ratio from 180 to 210 is 30. The distance there is 30, and we're going 15 parts of it. So we're 15 to 30 is equal to x over 1.5, right? So you can set up a ratio if you want, or you can probably see that we're going to be halfway between these, or 2.75 degrees west deviation, right? And so that's too accurate for Coast Guard problems. You don't need to do that, but we'll leave it in there for now. And so if you kind of do out this math, 195 magnetic plus 2.75 west, rounded to the nearest half degree increment, you'll end up at 198 degrees PSC, right? And that would be the answer given to you on a Coast Guard question in a multiple choice format, right? So all we did is we used our regular acronym, True Vampires Make Dull Companions at Wakes. We plugged in what we knew. We looked into the deviation table. We mentally interpolated is the word for that, the vocab word, to get where we needed to be. And then we can solve our problem that way. All right, so in summary, just a quick review. What we did is we talked about why this, although we think of it as a magnetic compass, is not actually a magnetic compass in terms of this, it's a compass. So this right here is your C value. If you want to turn it into a magnetic value, you have to account for deviation. An example of deviation is the compass spinning because you put a phone next to it or something. Metal, electronics, electricity in there, right? The other type of thing we need to account for is variation. Variation has to do with the Earth. The short version is it's the difference between true north and magnetic north. The longer version is it's the angular difference between the geographic meridian or line of longitude and the magnetic meridian or line of longitude, so that angular difference. Variation and deviation combined are called compass error, and you're always going to be moving between two different values, true and compass, with magnetic as an intermediary to get there. We also talked about gyro error, what a gyro is, what gyro error is. The acronym for that is GET, gyro plus easterly error is true, or gyro best, error west, gyro least, error east, if you want to remember that. And then we also solved for deviation in this problem. We solved for compass, we solved for true, and these are types of problems you're going to see as parts of larger problems. So this is a fundamental skill set. I would encourage you to practice these, and it'll only make your life easier as you go forward. You're going to see them in chart plotting a lot. You're going to see them sometimes in the navigation general category. And finally, you'll definitely see them in the navigation problems, both at the near coastal and the oceans level. All right, so I'll end there. If there's any questions, I'll stick around for a few moments in the chat box there. All of the questions are located in the video description below or in the chart window or the chat window there. So thanks for your time. All right, you're welcome, Guy. Thanks for watching. You're welcome, David. Thanks. So Mick, if you're still there, you're testing on Monday. Anything you want to go over? Alrighty, Paula, thanks for watching. So yeah, testing at the regional exam center can be a tricky experience. It can be intimidating, but if you study hard, you're going to be good to go. One thing that they often will do to you is make you take rules of the road first. Some regional exam centers do that, some don't. So be ready for that right away. And then the other thing is you have to take at least 2 exams per day. So my strategy for when I go to tests and I have to take like 8 tests or something is study rules of the road. I get that out of the way first, and then I try and pick an easy one for the afternoon. And then I purge that information, and then over the course of the evening, I then study for the next day. So I like to break my subjects up so that I've got a hard test in the morning and an easier test in the afternoon. Everybody's got a different strength and weakness. For me, navigation is a strength, and then deck safety and engineering is a weakness of mine. So I try and cram all that stuff as well. But all the folks at the Regional Exam Center are wonderful folks, and they'll hook you up and help you. John, great question on the gyro correcting thing. Can you plug it directly in? And so I guess what you're asking is, can you go like this? Yes, you can. Oh, I forgot the V, sorry. You got to be careful though, because if you remember that memory aid, gyro plus easterly error equals true, right? You're adding east in this way, but there's a break here. Now you start adding west again. So I personally prefer to keep them separate, right? But the T in the gyro one and the T in the PSE one is the same T. So I like to write it like this, and then TVMDC. So your question is this the same? Yes, it is. And if you write it this way, you won't get confused. Hopefully I'm illustrating the point correctly. Gyro plus easterly error is true, but on this one over here, you subtract easterly things and you add westerly things. So that's a great question. This is my preferred way of keeping myself organized there. Thanks. Using a sextant? Yeah, for sure. So one of the video series that I have on the YouTube channel is kind of the basic sextant stuff. If you kind of search around, you should find that. If you go to my website, I've consolidated all that into a free course you can enroll in and have all the have access to all the videos as well. What we're going to do over the next 6 or 7 weeks in this little semester that we're running is solve navigation problems. So I probably won't be actually holding a sextant per se, but we will talk sextant problems in a future episode. So thanks. Oh, okay, let's see, John. So putting them side by side with gyro in the spot of magnetic. So the G goes here. Not exactly, yeah. So variation and deviation are only going to be between true and compass. Gyro is kind of between gyro and true. So you have to keep them separated either in this way or in another way. You can't necessarily substitute gyro for magnetic. The gyro compass on the ship is kind of located down in the bowels of the vessel. It's an electronic piece of equipment. It has repeaters that come up onto the bridge, so you can read the gyro heading. Most larger ships are going to use that as their primary means of steering. Only smaller vessels are going to use something like this as a steering compass. So yeah, John, I really recommend keep the gyro stuff over here, keep the compass stuff over there, and that way you won't get mixed up with the problems there. All right, thanks, Paula. Actually, if you're into sextants, you definitely want to check that video out, because as far as I know, I'm the only one with flame decals on my sextant. So if that intrigues you, go check it out. All right, sounds good, everybody. Thanks for watching. This video will be archived on the site forever. And then practicalnavigator.org for lots more free and discount courses. If you got any questions, Chris@practicalnavigator.org. And if you're studying for your license, good luck, and thanks for watching.